Hello learners and viewers, welcome to our today's class. Today we are going to discuss about physics, and we are going to look at a problem from the topic of turning effect of a force. And I'm telling you, this thing is wild. So tune in and enjoy. Thank you. Now the question reads, the figure below shows a wheel of mass 120 kg and radius 1.2 meters being pulled by a horizontal force F against a metal block of height 0.4 meters. Calculate the initial force F, which is just sufficient to turn the wheel so that it raises over the metal block. So, for you to solve this problem, you need to have the concept of turning effect of a force, that the principle of moments, that clockwise moment at a point must be equal to anticlockwise moments about the same point. So you have been told that this is the metal block, and this particular wheel has a radius of 1.2 meters, and the weight is 1200 Newton because it has a mass of 120 kg. So you want to find the value of F, the weight, the force just sufficient to turn the wheel over the metal block. So first thing that we need to know, we need to write, actually you write that the sum of clockwise moments must be equal to the sum of anti-clockwise moment. That is very key. You must write that. So, to come to our diagram, we are saying that this is the metal block, and this particular metal block has a height of 0.4 meters. Now if we can extrapolate this, we find that from here to here it is 1.2 meters, but 0.4 has taken it, so we are remaining with 0.8 meters. Correct? So let us draw this triangle. We are having this particular triangle. We have been told that the radius of the circle is 1.2, so it just remains to be 1.2, and this distance from here to here is also 1.2, but this metal block has taken 0.4, so what are we remaining with? We are remaining with 0.8. So using Pythagoras theorem, you can find this distance x by saying that 1.2 squared minus 0.8 squared should give you x squared. So if you do that, you get 0.8 should be equal to x squared. If you do the square root, x should be equal to, let me use my calculator so that we go faster. So the square root of 0.8, you see the numbers, so we're going to have 0.8944 meters. Let us leave it in 4 significant figures. So we leave it in 4 significant figures. So that is that. Now we have found now the distance, this distance as x, the distance x. We have found it. So in moments, you know that the sum of clockwise moments must be equal to the sum of anticlockwise moments. So we're going to say, so you need to identify actually where are the anticlockwise moment and where is the clockwise moment. Is it okay? So the clockwise moment is this w. So the w times x should give us f times radius. Is it okay? Are you getting this? That the w times x should give us the force times that radius. Now our w is 1200. So 1200 times 0.8944 should give us f times 0.8. Somebody may ask me, why are you using 0.8? 0.8 because the distance here is 0.8. As in this our triangle, if you can see, this is where this force is acting, F. That is where the F is acting, and the weight is acting here. So we're having something like this. So when we're having something like this, means clockwise moments is this weight and this, and the clockwise moment is this and this. Are you getting that? Yeah, that's why you're using 0.8. So your F, if you substitute, should be 1341.6 Newton, and that is a tick. So this question can go up to 4 marks. So I hope you have learned, and now you know if you didn't know, and if you did not understand, now you have understood. So when you're told to find that, just do like that. Yes. Thank you and have a nice day. Don't forget to share and subscribe.